Welcome to this video where you will learn how to create collections and vector embeddings using Chroma DB. After watching this video, you will be able to explain the purpose of a collection, explain the characteristics of embeddings, and describe how to create a collection and embeddings in a Chroma DB vector database. In a Chroma vector database, a collection functions like a relational database table. The collection is a container for storing sets of vector embeddings, documents, and associated metadata within a vector database. Let's learn more. Chroma uses vector embeddings and numerical data representations, including text, images, and audio. Documents stored in the collection contain the original text, image, and video data with their corresponding embeddings. You can attach metadata, including labels or tags, to the data stored in the collection. Including the metadata with the item enables more nuanced filtering and retrieval of information. In summary, think of a collection as a categorized folder that groups similar data, including its embeddings, documents, and metadata, using a designated name, which improves information retrieval and management. Now, let's learn about embeddings. In a vector database, an embedding is a special type of data representation. An embedding is a fixed-length list of numbers that captures the meaning and relationship of a data point in a high-dimensional space. Each number represents a dimension or characteristic of that vector. For example, you could represent text, an image, or a video as vector data using the following numbers: 0.2, 0.4, 0.6, and 0.7. An embedding, also known as a vector embedding, is the complete set of numbers related to the document. The collection analyzes embeddings to evaluate the similarity of items or objects within the collection. For example, the vector for dog is 0.123, 0.456, and so on until 0.789. The vector for the data object dog might have 50 to 300 dimensions with characteristics of this specific data. So if you examine words similar to dog, which let's say is dogs, and 0.85, you'll see the following words that are related to the word dog: puppy, pet, canine, and puppies. So, the vector for the dog line shows the vector representation of the word dog in the embedding space. Each number represents a dimension of the vector. Here, dimensions mean several points or sets. The words similar to dog line lists the top 5 words most similar to dog, along with their similarity scores. The similarity scores indicate how close these words are to dog in the embedding space, with higher scores indicating greater similarity. Next, let's examine the steps and code you'll use to create a collection and generate embeddings within the collection. The following JavaScript code uses a Chroma DB vector database library to create a collection and add text data to the collection after converting the text into embeddings. Here's a step-by-step explanation. The code's first task is importing the components from the Chroma DB library. Then, the code imports the Chroma client, establishing the connection with the Chroma server. Chroma functions will interact with the server connection. Now it's time to define the default embedding function. A variable named default_EF is created and assigned a new instance of default embedding function. The code uses this function later to generate numerical representations from the textual data, which are the embeddings. Next, you'll see the code defines an asynchronous function named generate_and_add. This function will handle creating a collection in Chroma, adding documents with embeddings, and potentially performing other tasks. The next part of the code creates the collection. Inside the generate_and_add function, the code creates a Chroma collection using client.createCollection. In this code sample, collection name is set to my_collection21. The embeddings property specifies that the code will use the default_EF function that the code created earlier to generate embeddings for documents added to this collection. And now, with your collection created, this code can generate embeddings. The code called default_EF.generate to create embeddings for a list of sample data items, which in this case are text strings. Note that this code demonstrates batch embedding generation, but you can also generate embeddings for individual documents. You might find that you can add a document with embeddings using the following method. Inside .then callback, which exists after generating the embeddings, the code attempts to add documents to the collection using collection.add. The collection logs the generated embeddings and their numbers and sends them to the console for verification. In this pictorial representation of a collection, all of these vector embeddings are like points on the map. Now, all those embeddings are visible, and the collection can determine the distance or closeness of each vector relative to the others. After running this file in your code editor, the code will display the embedding data. And that's how you create a collection and embeddings using Chroma DB. In this video, you learn that within a vector database, the collection is a container for storing sets of vector embeddings, documents, and associated metadata. An embedding is a fixed-length list of numbers that captures the meaning and relationship of a data point in a high-dimensional space. And to create a collection and embeddings in Chroma DB, you create code that imports the Chroma DB components, sets up the collection and embedding functions, creates your collection, and generates your embeddings.